Hi everyone, welcome to my lesson Introduction to 2D Vector Addition. In this video, I'll show you a visual representation of what adding vectors looks like. So just a quick recap first, we can use arrows to diagrammatically represent vectors. Their magnitude is given by the length of the arrow and the direction by the direction of the arrowhead. So what does the visual representation of adding vectors look like? Well, we can put the tail of the vector being added onto the head of the other vector, and then the sum formed is referred to as the resultant. So here we're adding vector b to vector a. We put the tail of vector b onto the head of vector a, like this, and the resultant will go from the tail of vector a to the head of vector b. Does the order in which we add those two vectors matter? So if I add vector b to vector a as opposed to vector a to vector b, will the resultant vector be the same? Well, it turns out that vector addition is commutative, so the order in which vectors are added doesn't matter. And that's true for adding 2 vectors, 3 vectors, 4 vectors, or even more. Any permutation of vectors will give you the same, or any permutation of vectors which are being added will result in the same resultant vector. So that's in a similar way to adding numbers. It doesn't matter which order you add a list of numbers in, you'll get the same total. So let's look at an example of adding 3 vectors. So yeah, we can line up vector b, on tail of vector b on vector a, tail of vector c on vector b. From the tail of vector a to the head of vector c will be our resultant vector. Now just to reinforce my point about commutativity, here we can see it doesn't matter which order we add vectors in, whether it's vector a plus vector b plus vector c, or vector a plus vector c plus vector b, or any other of the 6 permutations. And the reason why we know it's 6 permutations, just as a bit of trivia, is it's 3 factorial. 3 by 2 by 1, because we're adding 3 vectors together. That's not important for vector addition, but that's something that might interest you. What about subtracting a vector? Well, it turns out that subtracting a vector is the same as adding a negative of that vector. So vector a minus vector b is the same thing as vector a plus the negative of vector b. And then from there, it's just the same thing as before, and form a resultant vector. Okay, to conclude, the tail of the vector being added is put onto the head of the other vector. The sum formed is referred to as the resultant. The addition of vectors is commutative, and that means that the order in which the vectors are added doesn't matter, and that's true for 2, 3, 4, or even more vectors being added. Any permutation in which you add the vectors, it will result in the same resultant vector. In my next video, I'm going to introduce you to the concept of resolving a vector into horizontal and vertical components. That is an important skill which you will need for when you are adding vectors together. Thanks for watching, and please feel free to subscribe.